Okay, so for this video, a couple of word problems involving rational expressions and rational equations. These are going to be distance, rate, time problems. They're very similar. A lot of books ask them in very similar ways. It's more of a, do you understand how to convert the problem to something that you recognize more than solve this rational expression or rational equation, I should say. So one of the issues is that people kind of get overwhelmed by the amount of stuff that they present you. So what I tend to do is I tend to try to identify what I'm going to need first. So I'm going to, let's change some of these colors up a little bit. But all right, so I am going to decide which one of these do I need. Do I need that one? Do I need this one? And do I need this one? I don't know. And so I'm just going to write them all down. Now, of all of these, I remember this one, and I derive the other two, meaning I just solve for D or T depending on what I need. The reason I do this is because this is my speedometer. R stands for rate, and rate is a distance over time. I can look down at my speedometer and say how fast am I going, and it's miles per hour or kilometers per hour. Either way, it's a distance divided by a time. So this helps me remember exactly what I'm supposed to be doing. Obviously, if you're not driving, then, this might not work for you. Well, let's try this out. What's the worst that could possibly happen, right? All right, so I am going to start not with the first sentence. If you've watched my other videos, you notice I don't start by reading the problem like the vast majority of people tell you to do. I actually start by going to the question. What was his speed in the motorboat? Perfect. All right, so, and then before I start the problem, I need to know what his speed in the motorboat was. So what am I looking for? Well, then my variable x is going to stand for the speed of the motorboat. Or a boat, if you're Dr. Doofenshmirtz. And then I'm going to go back through, and I'm going to start reading through the problem and see if I can pull out something else. So Bill wanted to try out different watercraft. That whole sentence is complete bunk. Nobody cares. He went 62 miles downstream in a motorboat and 27 miles downstream on a jet ski. Okay, so now we need to know something about the jet ski. So if we've got the speed of the motorboat, we need the speed of the jet ski. And because I got this feeling we're not going to be told the speed of the jet ski, because that would be too easy. His speed on the jet ski. All right, here we go. His speed on the jet ski was 10 miles an hour faster than the motorboat. So if I tell you that you're going 50 miles an hour, and then I say I'm going 10 miles an hour faster, you would say, okay, well, you're going 60 miles an hour. The 60 is not the important piece. The important piece is how you used 50 and 10 to get to 60. What I'm doing is I'm essentially giving you an analogous situation to this to try to figure out, what do I have to do in order to get there? So his speed on the jet ski was 10 miles an hour faster than the motorboat. You would have told me to take 50 and add 10. Okay, that's how you get to 60. The exact same thing happens here. You take what you know, the motorboat, you know it's x. Why? Because that's what you called it. So we called it x. We want to add 10 miles an hour to it. Okay. So these are our variables. We're just kind of putting them off to the side. Notice that I only have one true variable. I've got two different speeds here, but only one true variable. So now I'm going to go through. Now that I've got that, let's erase some of this stuff. We already did that piece. We don't need that, but we'll leave that uncovered. Okay, this next piece. I need to figure out which one of these three equations I'm going to need. So I'm looking at this sentence here. And I'm going to read it very carefully, and I'm going to try to understand it. So Bill spent a total of 4 hours on the water. There are two great big pieces of information here that I need to understand. The 4 hours and what it means to total something. And so if you were to say lay $1, $3, and $5 on the table, and I said, well, what's the total amount? And you'd say, well, it's $9. I'd say, how'd you get it? Well, I added. What does total mean to do? To add. Okay. So we are adding. We are adding to get 4 hours. If we're adding to get 4 hours, that means we're adding time. We can't add miles per hour and distance and get time. It doesn't work like that. So what we're doing is we're adding the two times together to get 4 hours. That's telling you the setup and what you need out of these three. To address this particular one, and for my students, it's the one this is almost entirely used throughout the entire assignment. You are going to choose the T equals D over R because it's talking about time, and we need to add time together. So I'm going to kind of do this in steps. I'm not going to spend as much time on the next one because it quite literally is the same idea, but I want to really hammer home the setup of this problem and how I gather all of the information and put it together to come up with a decision. Green's fine. We'll do green. So I need a time. So I need a time, and this is going to be for my motorboat. The subscript here is just telling you what the T is measuring. And then I need to add that. That's where I got the total. I need to add that to the time on my jet ski. And I get 4 hours out of that. So as we're moving through this, I notice that time is equal to distance over rate. All right. Well, if I'm talking about the motorboat, then what I need to do is I need the time of the motorboat, so I need the distance of the motorboat and the rate of the motorboat. Those are the two things I need. I can't mix and match. So the distance of the motorboat, he went 62 miles downstream in a motorboat. So the distance was 62. And it's 62 miles. I'm going to put that here. The rate of the motorboat, and we are adding 10 to it, so our rate is in miles per hour. So this is going to be X, but it's going to be in miles per hour. This is important. Not all of your problems are going to have matching units. The units must match. You cannot intermingle units here. So if, for instance, it gave me 62 kilometers, but it gave me the speed in miles per hour, you must change one of those because they do not agree. If it said he spent a total of 30 minutes on the water, well, I have a rate of miles per hour. I can't use 30 minutes. I have to use hours, or I have to change it into miles per minute or feet per minute or whatever. It's going to be easier, just call it half an hour. But point being is all of your units must agree. If they don't, you need to change them so that they do. So this is for my motorboat. My units agree, so I'm moving on. Now for my jet ski. My time is equal to the distance over the rate. I went 27 miles. Notice I'm just saying I instead of Bill, because I really don't care what the person's name is. I'm putting myself in this problem so that I can better understand it and kind of walk through it in a sense. 27 miles on a jet downstream on a jet ski. His speed on the jet ski was 10 miles. Okay, so I need my speed, and my speed of the jet ski is X plus 10, and that's also in miles per hour. That whole thing is. All right, so what that's going to mean is if you were to go through and do the dimensional analysis, which is a fancy way of saying cancel out all the units that you can, you're going to cancel the miles. The hours are actually going to pop up top, and you'll find out that both of these things are in fact measuring in hours. All we have to do now is throw them where they need to be. I'm going to ignore the units. I've already done my unit analysis separate of that. And so I'm not going to carry those with me because it's just going to confuse me. The time of my motorboat, that's the 62 over x. So 62 over x. And then I'm adding. So I'm going to bring this adding in here. And then my time on the jet ski is 27 over x plus 10. Don't forget that x plus 10 is entirely captured by the fraction bar. And finally, that's going to equal 4. You are now about 70% done with the problem. This is the hardest 70% of the problem. The rest of this is just solving, and it's relatively easy by comparison. At least in my opinion, I struggle with it. All right, so now for the solution part. We're going to go ahead and this is a me thing. It does not have to be a you thing. If you want to operate on the left-hand side of this equation, just get a common denominator, and then you can combine the fractions. I almost invariably just go through and cancel out the fractions. So to do so, I need to multiply by the least common multiple or a common multiple of all of the denominators. An easy way to do this is just to say, I'm going to multiply by every denominator that's listed. The 4 doesn't have a denominator other than 1, so 1 doesn't affect this. That's kind of nice. All right. As I proceed through the solution, I'm going to take this whole thing here, and as I multiply through, that's coming in on the top. So this is a fraction over 1, so everything multiplies the numerators. Now, my students already know this. If you're not one of my students, but you've watched other videos, you already know this. I'm a stickler for order of operations and what they really mean. So I'm going to bring in a multiple on top, and I'm also dividing. Multiplication and division are the same thing. They occur at the same time, which means you can choose to do one over the other first, as long as that's all you're doing. I know I'm going to get somebody coming, but I did it on a... Yeah, there was addition involved. That's why it didn't work. As long as you're only multiplying and dividing, you can choose to do it in any order you want. So I'm going to do it in an order that's advantageous to me. When I bring this x and x plus 10 over to the 62, I notice I'm also dividing by x. Well, the speed of the motorboat can't be 0. So I've already determined that that's not possible. And x can't be negative 10 because that means we're going in reverse. That doesn't make any sense. So I don't have any restrictions really on x other than what's physically possible. That means that x is non-zero. I can go ahead and divide by it. So any x divided by an x is going to give me 1. They cancel out, leaving me with 62 and this x plus 10. By the same argument, on the next term, my x plus 10s are going to cancel when I bring this through and distribute it. And therefore, I'm left with 27 and an x. And there's nothing to really cancel that would be beneficial over here with the 4, and so it's just 4x and x plus 10. I'm not going to expand that at the moment because I'm going to expand it all at once here. Don't do too many things at once. That's the kiss of death for most people. All right, so drawing my little things in here because otherwise I'll screw it up. 62x plus, and then multiplying by 10 adds a 0, so it's just 620 plus 27x is equal to 4x squared plus 40x. It's up to you how you want to do this. I typically do not combine like terms. I just move everything over to one side. You'll notice that I have an x squared term. That just says get everything to one side and then make the other side 0. So I'm going to do this in a couple of different steps. You're going to have to follow the arrows because I'm running out of space here. So I'm going to combine like terms. So I have a positive 62x, I have a positive 27x. That's going to give me a positive 89x plus 620 is equal to 4x squared plus 40x. Okay. You're like, but do I have to write all of this stuff down? No, you don't have to. Do as much as you can or as much as you want in your head. But understand, the more that you try to cram into your noggin, the more likely you are to make mistakes. This is just a way to, for me, it's like working memory. I'm just writing it down so I don't forget it. All right, so now I'm going to subtract 89x from both sides. And then at the same time, I'm going to subtract off 620 from both sides. If you're not comfortable with that, take 2 steps to do it. But this is going to be 0, this is going to be 0, leaving me with, if I bring down my arrows, 0 is equal to, and then this is going to be 4x squared minus 49x minus 620. All right, I'm sure that at some point I'm going to get comments like, oh, well, why did you move everything to the right? I like everything to the left. That's fine. It doesn't matter which way you move it. I like to have all of my leading coefficients positive if I can, because that way I don't have to worry about dividing through by negative numbers, and it makes it easier. So that's why I choose to do it. Now comes the fun part. You're going to have to go watch other videos if you want to do it a different way, but I don't really want this to last 20 minutes to factor this. So I'm going to do it my way. And so I'm going to factor the front and the back separately. And I'm going to guess. I'm going to start with 10 and 62, and then I'm going to see what happens there. All right, so I've got 40. That's too much. That's not going to be enough. All right, so I'm going to take 20 and 31. The reason I chose this is because I can multiply 10 by 2 and divide 62 by 2. And that gives me the same thing. Multiply 20 by 31, you'll get 620. All right, so this is going to give me 20. This is going to give me 11 difference, so that's going to give me 22 difference. That's not good. 80, and I got it. It's right here. Okay, sweet. It didn't take me that long. 4 and 20 is 80. 1 and 31 is 31. I have to subtract in order to make 49. So 80 minus 31 is in fact 49. All right, so you're wondering like, okay, well, that's nice. What does that tell me? It actually gives you all 4. So the factoring is this. 0 is equal to. My signs are different according to the negative on the 620. The larger of this pairing takes the negative according to the 49. So I need an x and I need a 4x. And the 20 has to multiply into the 4x, so it cannot be part of that. But it has to be negative, because the larger one has to be negative. That means that the 31 comes along in the 4x factor. Okay, so just double check. X times 4x is 4x squared. I have negative 80x plus 31x gives me a negative 49x. And then 20 times 31 is in fact 620, and a negative times a positive is a negative. Okay, so it works. Well, that means that I have to, if I have two numbers that multiply to give me a 0, by theorem, not by assumption or by definition, but by theorem, then one of these numbers must be 0. Which one? I don't know either. So we just test both of them. 0 is equal to x minus 20, or 0 is equal to 4x plus 31. Now, simple test. If I subtract 31 here, then I'm going to get a negative amount for my x. My x is the speed of the motorboat. Cannot be negative. That is not going to work. So I completely ignore that solution. That is called an extraneous solution. It has to do with how the technique of what technique you used to solve the problem. It introduced a solution that was untrue. So that's why we have to double check these things. Over here, we get 20 is equal to x when we solve for x. Then what we're going to do once we're done with this is we're going to kind of go back and check to make sure it makes physical sense. All right, so I'm saying that my motorboat went 20 miles an hour and that my jet ski went 30 miles an hour. Is it possible to go 20 miles an hour on water? Yeah. I mean, my monster pontoon with the tiny little 40-horse motor on it is still going to get 15 miles an hour on the water. So yeah, sure. Motorboat will easily do 20. Jet ski do 30? Yeah. Pretty easy. So, it makes physical sense. You can go ahead and plug the 20 back into this equation if you want to test it. What you're doing, though, is you're testing your algebra, not the problem. That's why you kind of go back and say, is it physically possible? Because you're also testing the solution against the original problem itself, not just the algebra. All right, well, that took me a long time. I'm not going to substitute that in to see if it's true, but if you want, by all means, go right ahead. I'm just going to assume, I'm going to do what most people do and just assume that I'm right. So my answer is x equals 20, and x was the speed of the motorboat, and I was asked what was his speed in the motorboat. I've answered the question. That is it. All right. So, I mean, that's not too bad. It took us, 20 minutes? That's seems a bit long. So, I'm going to go ahead and make a separate video on Devontre riding his bike, and then I'll post that as well. All right. Take a look back at multiple parts of this. There's a lot going on in this problem, so don't be afraid to go back and review some of it. All right. Hope this helps.